Okay, so today it is, it's May, hallelujah, May 2nd. Our objective today is to talk about the characteristics of parallelograms. Okay, write that down. Right? Camille, write that down. Characteristics of parallelograms. So there's a lot of things about parallelograms that are important. So first of all, let's go straight to the definition, though. Definition's different. A parallelogram is called a parallelogram because of parallel sides. Does that make sense? So that is its definition. So it is a quadrilateral, with two sets. Did you not get it? Two sets of parallel sides. That's it. That's a parallelogram. So I'm going to draw one out because I get one of these cool little template things so I can draw it so it looks nice. There it is. There's a parallelogram. I'll label it A, B, C, D. So we have parallelogram, bad looking parallelogram, A, B, C, D, okay? That's symbolism. I tried to draw a little itty bitty parallelogram. I'm not much of an artist, but that's my little itty bitty parallelogram A, B, C, D, okay? So if it's parallel, let's take a look at what we have. Right off the bat, I do know that, watch this, this side is parallel to this side. And that's how we show it on a figure. We draw the little arrows. So if you see the little arrows like that, you know that AD is parallel to BC. We know that just because it's a parallelogram. And watch this. Double arrow, double arrow, double arrow. And we use double arrows because it's not parallel to AD, but we also know then that we could say DC is parallel to AB, right? And that's just how we show the parallel with those arrows. When you see these arrows in a geometric figure, it's saying that's parallel to that, okay? We know that. Now, there's some things about a parallelogram that we also know. Characteristics. We just went through the theorems. One, that opposite sides are equal, right? So when we know AD is equal to BC, and we also know that AB is equal to DC. Right? Everybody agree with that? Opposite sides are equal. That's one of the characteristics. If it's a parallelogram, opposite sides are equal. Either you're totally bored because you already know this, or you're like kind of grateful that we're doing something easy. What do you think? Grateful we're doing something easy? Okay, two, what else do we know? Well, we know opposite angles are equal. Opposite angles are equal. So we can go the measure of angle A is equal to the measure of angle C. That little m means measure. That little m means measure. And we also know the measure of angle D is equal to the measure of angle B, right? Opposite angles are equal. What else do we know? Well, we know that consecutive, that means right next to each other, consecutive angles are supplementary. So I could say that the measure of angle A plus the measure of angle D equals 180 degrees, because supplementary means 180. Supplementary means 180. We learned that some time ago. It's been a while. But supplementary means they add up to 180, okay? What else do we know? Well, one more thing. Diagonals bisect each other. So let me draw those in. Let's see. This color here in my ruler. So diagonals, those are the lines that go through it from angle to angle. Here's my diagonals. There's a diagonal. And there's a diagonal, okay. And I've got a intersection, so I'm going to call that, how about X, huh? Point X. They're not equal. They don't look equal. I mean, the length of AC does not look equal to the length of DB. You guys agree? I mean, that looks longer than that one. But what we do know is they cut each other in half. So we can say that this side is equal to this side. So we can say that AX is equal to XC, and this side is equal to this side. It cuts the diagonals in half. And we can also say that DX is equal to XB. Okay, those are all the characteristics. So if we know that, then we're just going to do some problems. We're going to solve problems taking what we know, okay? Okay, slide it up. You guys ready for example 1, or am I going too fast? Okay. So example 1, there's a parallelogram. Okay, so if it's a parallelogram, find x, y, and the length of AB. So first of all, when I look at this problem, 4x and y, yeah, two different variables. I'm not going to mess with it, but I do know I'm going to go right here. I'm going to start right here, okay? Those two are equal, and I can solve for x. You guys agree? I'm going to start right here. I'm going to start with my x plus 18 equals my 3x minus 2. Let's begin there. I know these two sides are equal because it's a parallelogram. So x plus 18 has to equal 3x minus 2. We're just going to solve for x, which we're good at. We're good at solving for x. All right, so minus x, right? 18 is equal to 2x minus 2. Plus 2 plus 2. 20 is equal to 2x. Divide by 2, x is 10. But that's not the answer. That's not the answer, okay? So, if x is 10, let's take that, put it right there, okay? So, AD is 40. You guys okay with that? 40, because if x is 10, AD is 40. That means y has to be 40 because they're equal. So, I know that y is equal to 40, right? We also want to know the value of AB. Well, okay, again, I'm going to take my 10. Plug my 10 right into there. So I'll go 10 plus 18 is 28. So the length of AB is 28. How am I doing? Does it seem pretty easy? I'm hoping it is. I mean, I think this is stuff you guys already know, okay? Okay. Example 2. Am I going too fast? Grace, been doing okay? Okay, now, it's a parallelogram. Let's see here. See the same problem here. I got x and y. I'm not going to mess with these two. That's an x and that's a y. But I can find out the value of x is right here. And that will help me, right? So let's do this. I know opposite angles are equal, right? So I'm going to go straight to saying that 49 is equal to 4x minus 37. All right. Let's find out what the value of x is. Well, plus 37 plus 37. Oh, what's that? 86? I think so. 86 equals 4x. Divide by 4. Might need my calculator here. 22 and a half or something like that. Hold on. What's 86 divided by 4? 21 and a half. I was close. Divide by 4. Divide by 4, and I get a 21.5 is the value of x. Now, if I know that, then I can find y. All right, to get y, I'm going to take the 21.5 and plug it right there. Okay, right there. Okay, so I'll go 4 times 21.5 minus 3, and I'm probably just going to use a calculator to do the math. Why not? I'll just go 4 times 21.3, 21.5, my bad. Subtract 3.
83.
Huh?
83.
83. You're way ahead of me. I like that. So that means this side's 83. That means this side's also 83. You guys agree? So to find y, I'm going to take my 83 and set it equal to a 1/5 y. Now, a lot of kids have forgotten how to solve for y right here, okay? So think about it. Solve for y. I have to undo it. Well, I'm going to undo it. So I'm going to multiply by its fraction. I'm going to multiply by its reciprocal. You okay with that? So if I multiply this by 5 over 1 and 5 over 1, I'll get 5 times 83. I get 415 for the value of y. Okay, you guys remember how to multiply by reciprocals? Remember how I did that before? How am I doing? Thumbs up, easy peasy, lemon squeezy. I'll turn it in just a second. Okay, and turn the page. All right, now, okay, find the coordinate of the intersection of the diagonals of this parallelogram. Okay, we're looking for the diagonals, but let's graph first. Point A, 0, 0, right there. B is 1, 1, 2, 3. There's B. C is 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There's D. And, I'm sorry, C. My bad. It's Monday. D is 5, 1. 1, 2, 3, 4, 5, 1. Okay. All right. Let me go ahead and connect the dots. There's my parallelogram. Okay. Connect my dots. Diagonals. Okay, well, let's see. Let me draw them first. Let me draw my diagonals. Diagonals are like, oh, I think I got it. I think I know what the point of intersection is. I'm staring right at it. Nice. Must be right there. Must be right there. So the answer is that point. The answer is the point at 1, 2, 3, 1, 2, point 3, 2. That was easy, wasn't it? All right. Example 4. Let's see. So let's graph 1, negative 1. There's A. 0, 2. There's B. 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's C. Technically, there are 3 correct answers, and that might be an extra credit problem at some point in time, okay? Just giving you a hint. But technically, there could be a point way down here to make a parallelogram. Can you visualize that? There's a point way up here. Can you visualize that? And probably the easiest one is the ones over here, but there are 3 possible points. So extra credit on your next quiz is to come up with all 3. This is probably the one you're going to find the easiest, okay? So we know, here's how I do it. I know parallelograms, the slopes are equal because they're parallel, right? So if I were to draw in this side right here, AB, it has a slope of down 1, 2, 3 over 1. So if I go down 1, 2, 3 over 1, that has got to be D. It's got to be because of parallel sides, right? And I'll double check this. This is up 2 over 1, 2, 3, 4. Up 2 over 4. Yeah, point D has got to be the fourth point. Again, there are 3 of them, but that one will work. So my answer would be at the point 1, 2, 3, 4, 5, 1. What do you think? Thumbs up. Does that seem easy? I don't think this chapter is going to be hard for anybody. I'd like to pass out your homework and have you guys work on this in class with lots of time. Anybody need a little bit of a brain break? You guys want to go outside and take a little brain break real quick? Yes. Let's take a brain break. Let's go outside. We haven't played 21 for a long time, even though it's kind of